Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a problem number 10 which is based on a state space analysis. In this question we are going to find out a state vector. So first of all, let's see what is the question and what are the content and what are the elements are given in question, and then we'll move on to how to find out the state vectors. So first of all, question number 10. Problem number 10. A system is described by the state input and output equations, and my state variable model is x dash is equals to ax plus bu and y is equals to cx, where my a, b, c matrix is given as well as my u input matrix also given, that is del of t and u of t, and at the end we have the state vectors, initial values of state vectors, which is 0 and 3, and what is mentioned, we have to find out the state vector x. So how to find out state vector is, there is a one formula that we have studied in last numerical also. So first of all, we'll use that formula and then we will find out the Laplace inverse of two different elements. Now how to find out state vector is, I'll show you. Now basically we are going to use this state vector formula to find out the state vectors. So first of all, we are going to find out inverse Laplace transform of Si minus A inverse into x naught, where my x naught value is given 0 and 3, and then afterwards I'm going to find out Laplace inverse of Si minus A inverse B into U of S, where my B matrix is over here, my A matrix is mentioned over here, and at the end u of s value is mentioned over here, del of t into u of t. So u of s, which means we are going to find out the Laplace transform of del of t and u of t. Del of t Laplace transform is 1, but u of t Laplace transform is 1 by s. So we'll substitute that value over there, and then we'll move on to the whole Laplace transform, or we'll calculate Laplace transform whole bracket. So first of all, I will solve this part only. So first of all, what we want, Si minus A inverse. Basically Si minus A inverse means we are going to find out adjoint of Si minus A and determinant of Si minus A. Now first of all, we'll find out what is Si minus A. So Si minus A is nothing but we are going to subtract A matrix from the product of S into identity matrix. So we'll write, so look at it, I have written my A matrix value. Now first of all, we'll multiply S with I. So what you will get, this is the matrix after multiplying S with I, and then we'll write again my A matrix. Now just simply perform this subtraction. So after performing subtraction, what I have got, Si minus A matrix is this. Now first of all, I will find out Si minus A determinant, and then we'll calculate the adjoint of this. So the determinant of Si minus A, this A and D is multiplied, and then C and B product is subtracted from these two product. So I can say that we will first of all multiply A with D and minus B with C. So S into S is S square plus 2s, minus 1 into minus 3 is plus 3, but again we have minus sign, so we will write minus 3. So this is our equation or the matrix equation. Now we can find out the factors of this equation also. What will be the factors of this equation? I can say that my factors are plus 3 minus 1, because last term is always product of two digits, whereas mid term is always same addition of same digits. So plus 3 minus 1 is always minus 3. So last term is correct. Now what about middle term? Plus 3 minus 1, answer is plus 2. So I can say that I have two factors, S plus 3 and S minus 1. Now I'll find out adjoint of Si minus A. How to find out adjoint of Si minus A? Only do one thing, just replace these two elements, like D is placed on A and A is placed on D, and just multiply minus sign with these two elements. So what you will get? This is our result. I will substitute both this value in my equation of Si minus A inverse. So I can write this adjoint first of all, and here we have 1 upon Si minus A determinant, so we'll write 1 upon. Now This value I'm going to substitute in the state vector formula. Look at it. I have substituted my Si minus A inverse value over here. This is my adjoint and this one is my determinant, and I have multiplied with x naught, that is the initial values of state vectors or state variables. So first of all, I will multiply these two matrix. How to perform the multiplication? The row is multiplied with column. So s into 0 is 0, but 1 into 3 is 3. So my first element is 3. Now 3 into 0 is 0, but s plus 2 into 3 is. So what I'm going to do, I'm going to shift this value inside this matrix. And now we will find out first of all Laplace inverse of 3 s minus 1 s plus 3, and then later on 3 s plus 2 upon s minus 1 s plus 3, and then we'll substitute both these value in this formula. So first of all we'll find out the Laplace inverse of first element. So my first element is, I have mentioned over here. Now here I'm using the partial fraction method to calculate the inverse Laplace transform. As we have two factors, so we'll use two elements. Now just multiply this left hand side denominator on right hand side. So look at it, if I multiply these two elements with a, so automatically s minus 1 and s minus 1 will cancel. A is multiplied with s plus 3. Similarly with b, s plus 3 will get cancelled. S minus 1 is multiplied with b. Now I will substitute s equals to 1 in this equation, so automatically my b value will removed. So 1 minus 1 is 0, so 0 into b is 0, so you will get the answer only for a. So on left hand side we have a 3, but on right hand side this s is replaced by 1. 1 plus 3 is 4, so we'll have 4a. So my a becomes 3 by 4. Similarly I will calculate, or I will substitute s equals to minus 3. If I substitute minus 3 over here, minus 3 plus 3 becomes 0, so whole a value is removed. So you will get 3 on left hand side, but on right hand side what you have, minus 3 minus 1, answer is minus 4. And if I shift this minus 4 on left hand side, I'll get minus 3 by 4. Now substitute both this value in this formula. Now I'm going to apply inverse Laplace transform on both the sides. So Laplace inverse of 3 upon s minus 1 s plus 3 is, I'll take 3 by 4 constant, so I will write it outside. 1 upon s minus 1, the answer is a to the power t. I'll take minus 3 by 4 outside, so because it is a constant, and 1 upon s plus 3 is, this is the first element inverse Laplace. Now we will calculate the second element inverse Laplace. Now the second element is Laplace inverse of 3 into s plus 2 in denominator s minus 1 s plus 3. So first of all we will calculate the inverse Laplace, but by using partial fraction technique. Now just do the cross multiplication. I'll multiply this left hand side denominator on right hand side, so you can say that's s minus 1 will cancel. So a is multiplied with s plus 3, and similarly b is multiplied with s minus 1, because these two elements will get cancelled. So on left hand side you have, now I will substitute different values of s so that you will get answer of a and b. So first of all I will substitute s equals to 1. So if I substitute 1, 1 minus 1 becomes 0, so whole b is removed. Now look at here on left hand side, if I say this s is 1, then 1 plus 2 is 3, and 3 into 3 is 9, so we have 9 on left hand side. Now look at here on right hand side, s plus 3, that is if I replace this s by 1, then 1 plus 3 is 4, so we have 4 into a. Now I'll shift this 4 on left hand side, so what we will get, a is equals to 9 by 4. Now similarly I'll substitute s equals to minus 3. If I substitute minus 3 over here, minus 3 plus 3 becomes 0, so whole a value is removed. Now what we have on left hand side, if this s is replaced by minus 3, then minus 3 plus 2 is 1, that is minus 1, but minus 1 into 3 is minus 3. Now minus 3 I'm going to substitute over here. Minus 3 minus 1 is minus 4, so we have minus 4b. And if I shift this minus 4 on left hand side, what you will get? Both minus and will get cancelled. You will get b is equals to 3 by 4. Now substitute a and b value in this equation. Now apply inverse Laplace transform on both the sides. Laplace inverse of 3s plus 2 and in denominator s minus 1 s plus 3 is, first of all, 9 by 4 is a constant, so I'll write outside, and 1 upon s plus minus 1 is nothing but e to the power plus t. Now again I'll write 3 by 4 outside because it is a constant, and 1 upon s plus 3. Now 3 by 4 is a constant, that's why I've written outside, and 1 upon s plus 3 Laplace inverse is e to the power minus 3t, and this is the answer. Now we will find out the second part of answer, but before of that we will substitute this value in our matrix. Now look at here, I have substituted both the values of Laplace inverse in this matrix. Now we will solve the second part of state vector, that is Laplace inverse of si minus a inverse, which is multiplied with b and u of s. So the second part is Laplace inverse of si minus a inverse. Now here we have already calculated the si minus a inverse value. So look at it, I have substituted my b matrix over here, my u of s, that is u of t matrix over here, the del of t Laplace is 1 but u of t Laplace is 1 by s, and my si minus a inverse formula, that is adjoint of si minus a and determinant of si minus a, I have mentioned over here. Now first of all I will multiply these two brackets, and then the product of these two is multiplied with 1 and 1 by s, and the whole result is then after multiplied with this last value, and then I will going to find out the Laplace inverse of two elements. Now here we are going to perform a row column multiplication, means this row is multiplied with first column, and then again this row is multiplied with second column. So if I multiply first row with the first column, then you will get the first element. Similarly, if I multiply first row with the second column, then you will get the second element. So similarly we'll do with the next one also. So s into 1 is s, and 1 minus 2 is minus 2, so we can write s minus 2 is my first element. Now similarly we'll multiply this whole row with the second column, so that you will get the answer for second element. So s into 2 is 2s, and 1 into 0 is 0, so we'll write a 2s only. Now we'll do the same thing with the next one. So 3 into 1 is 3. Next, s plus 2 into minus 2, so we can write. Now the last, 3 into 2 is 6, but s plus 2 into 0 is 0. Now simply add these two terms, so what you will get? If I multiply this minus 2 inside, then you will get minus 2s. Minus 2 plus 2 is minus 4, but minus 4 plus 3 is plus 1. Now I'll multiply these two matrices. Now here we have 2 by 2 matrix and 2 cross 1 matrix. So these two elements are removed, so you will get answer but in 2 cross 1 matrix, that is 2 rows and single column. So I will multiply this whole row with this column, so you will get the first element of first row. Now again we'll multiply the second row with this column, so you will get the first element of second row. Now s minus 2 into 1 is s minus 2, but 2s into 1 by s, so ss get cancelled, we'll write plus 2 only. Now this minus 2s plus 1 is multiplied with 1, so I can say that we have, and then 6 into 1 by s is 6 by s, and this is going to be multiplied with plus 2 minus 2 will get cancelled, we'll write only s, and this matrix, or you can say this 1 upon s minus 1 s plus 3 is multiplied inside this matrix, so I can write Laplace inverse of s upon s minus 1, s plus 3. Now just look at here, just do the cross multiplication, means here the s is multiplied with this whole term, so you can say that s into minus 2s is 2 minus 2s square, s into 1 is s plus 6, and in denominator we have s, and this will be multiplied with this whole denominator. Now I'll find out the Laplace inverse of whole matrix. So well, first of all we'll find out Laplace inverse of the first element, and then we'll calculate the Laplace inverse of second element. So first of all we'll find out the Laplace inverse of first element, and the first element is s upon s minus 1 s plus 3. We'll use a partial fraction method to find out the Laplace inverse. So according to partial fraction, I can say that as we have a two factors, so we'll use a two elements or two constants. So as we have a two factors, so we'll use a two elements or two constants. So we have a, so we'll write a upon s minus 1 and b upon s plus 3. Now I'll multiply left hand side on right hand side. So s minus 1 and s minus 1 will get cancelled. So you have a is multiplied with s plus 3, and s plus 3 get cancelled. B is multiplied with s minus 1. Now I'll substitute s values in this equation so that you will get the answer of all the constant, that is a and b. So first of all I'll substitute s equal to 1. So look at here, this b value will get vanished, so we'll get answer only for a. So this s is replaced by 1, so I've written 1 on left hand side, and 1 plus 3 is 4, so we can write 4a. Now I'll shift this 4 on left hand side, so we'll get answer of a, which is 1 by 4. Now I will substitute next value, which is a minus 3. So on left hand side we will directly write minus 3. Now minus 3 plus 3 becomes 0, so whole value is replaced by 0. Now look at here, here this s is replaced by minus 3, so minus 3 minus 1 is minus 4, so we'll write minus 4b. I'll shift this minus 4 on left hand side, so we can say that minus sign get cancelled, and my b value is 3 by 4. I'll substitute these two values in my equation. Now if I apply inverse Laplace transform on both the sides, so the answer is I'll write constant of first. 1 upon s minus 1 is e to the power t. I'll take 3 by 4 constant outside. I'll take 3 by 4 constant outside. So 1 upon s plus 3 is, now so this is the Laplace inverse of this element. Now we'll find out the Laplace inverse of next element. Now we will find out the Laplace inverse of the second element. Here we have three factors already, so we will use three variables. Now we'll multiply this left hand side denominator on right hand side. So look at here, ss get cancelled, so s minus 1 s plus 3 is multiplied with a. Similarly s minus 1 s minus 1 will get cancelled, so s into s plus 3 is multiplied with b, and s plus 3 will get cancelled, so s into s minus 1 is multiplied with c. Now we will substitute the different values of s so that we will get the answer of a, b, c constant separately. So first of all I'll substitute s equals to 0 in this equation. So whole s terms replaced by 0, so you'll have a 6 only on the left hand side. Similarly this s and this s is replaced by 0, so whole product is replaced by 0, so automatically 0 plus 0 is 0, so I'm not going to write that value. We'll consider only e. So 0 minus 1 is minus 1, and 0 plus 3 is 3, but 3 into minus 1 is minus 3, so we have minus 3a. But if I shift this minus 3 on left hand side, my answer is minus 2. Now I'll substitute s equals to 1. So if I replace all the s by 1, then what will happen? Now I'll substitute s equals to 1 in this equation. So look at here on right hand side, 1 minus 1 becomes 0, so whole a term is replaced by 0. Similarly 1 minus 1 becomes 0, so whole c product term becomes 0, so I'm not going to write these two values, we'll write only s, or we can say the product with the b. Now look at here, 1 square is 1, so minus 2 into 1 is minus 2. This is my minus 1 plus 6, but here s is replaced by 1, so this doesn't matter at all. This s is replaced by 1, so 1 plus 3 is 4, so we'll write 4b on right hand side. Now 6 minus 3 is 3, and if I shift this 4 on left hand side, then you will get b is equals to 3 by 4. Now we'll substitute s is equals to minus 3. Now minus 3 square is 9, and 9 into minus 2 is minus 18. Now look at it. Here we have minus sign, so minus of minus is plus, so we'll write plus 3. The last one is plus 6. Now minus 3 plus 3 will get cancelled, minus 3 plus 3 will get cancelled, so whole b product term and c product term is removed or we replace by 0. So I'm not going to write that value, we'll write only a c value. So minus 3 minus 1 is minus 4, and this s is minus 3. Now 6 plus 3 is 9, but minus 18 plus 9, answer is minus 9. And minus 3 and minus 4 is plus 12, so we'll write 12c. Now if I shift this 12 on left hand side, then now I'll divide numerator and denominator by 3, so you will get c is equals to minus 3 by 4. Now I'm going to substitute a, b, c value in this equation. Now I have substituted my a, b, c value. Now we will apply inverse Laplace transform on both the sides. So what we will get? So minus 2 is a constant, and 1 by s is inverse is 1, so we'll write only 2. Next 3 by 4 is a constant, and 1 upon s minus 1 inverse is e to the power minus t. Now and the last one, this minus 3 by 4 is a constant, so I'll write first, and 1 upon s plus 3 is e to the power minus 3t, and for s minus 1 it is plus t. Now I'll substitute all this value in my main matrix, that is part 2 of state vectors. Now I'm going to substitute both these matrix values, that is Laplace inverse of si minus a inverse into x naught and Laplace inverse of si minus a inverse b into u of s in one equation, that is you will get the answer of state vector x. Look at here, I have substituted both the Laplace inverse values in my state variable, or you can say the state vector formula. Now simply how to perform the addition? The first element is added with first and second element is added with second. Now look at here, the first element is 3 by 4 e to the power t minus 3 by 4 e to the power minus 3t, and here we have 1 by 4 e to the power t and plus 3 by 4 e to the power minus 3t. So we can say that here we have opposite value of plus 3 by 4 e to the power 3t. So these two values get cancelled, so you will have only 3 by 4 plus 1 by 4, that is 1, and that 1 is multiplied with e to the power t, so our answer is only e to the power t. Now look at here, the minus 2 is a constant because we don't have any e to the power function multiplied on both the sides, so we'll have only minus 2. Then now 9 by 4 e to the power t and 3 by 4 e to the power t, you can take e to the power t common, so we'll write over here. So 9 by 4 plus 3 by 4, if the denominator part is common, so numerator always get added, so 9 plus 3 is 12 and 12 by 4 is always 3, so we'll write 3 here. Now here we have 3 by 4 e to the power minus 30, which is having plus sign, and here we have the opposite sign, that is minus, so both the term will get cancelled, so we'll have only this value, and this is nothing but my equation or matrix for state vectors. So please be careful while solving this question, because here we are going to do a different matrix multiplications, that is matrix multiplication with 2 cross 1 is multiplied with 2 by 2 matrix, or you can say 2 by 2 matrix is multiplied with 1 by 2 matrix. So please go through this numerical properly, so you will get the idea how to solve or how to obtain the state vectors. Thank you for watching this video. Stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.